Hi everyone. Which chapter is in deleted portion? Can you please let me know once? Someone, anyone, please.
Mathematical induction, I guess.
Okay, that is the only chapter which is principle of mathematical induction, right? And
Yes, sir.
anything
And
other than
math
that?
modeling also. Math
Modeling.
modeling, I don't. Yes, sir. I saw one lesson. Wait, sir. I'll check in that.
Mathematical reasoning there is.
Mathematical induction and mathematical reasoning, sir.
Yeah, mathematical reasoning is also not there, right? That
Sir,
means
yes, sir.
Yes, sir. Only
we
those
are
two.
done with limits and derivatives. So and see today. See, I think if you have done this mathematical, what is that? Introduction to 3D geometry that we are going to start today. I still haven't got the host access. So that chapter, it can be finished today because it's a very small chapter relative, right? Like two or three formulas are there. The section formula, distance formula, and the area or so those are the two topics which from which question is being asked in this chapter. So that is also relatively small chapter. So next chapter, which one you want to do? Maybe next Monday. Maybe one more class we'll need for 3D geometry, not more than that. Okay, we'll see if we can finish it today. Uh, and which chapter is remaining? Which chapter do you want me to do? Any chapter? Probability and statistics is there, right? And one more chapter which is linear inequalities, right? We haven't done it.
Yes, sir.
Yeah, so linear inequalities, you guys might already have done that chapter, right? Inequalities,
Yes,
is it
sir.
done in your school?
Yes, sir.
So which one you want me to do next? Tell me, we'll start like that. Just a minute. Okay, so we'll get the host access in a few minutes. All right. So which chapter do we you want to do next? Like statistics and probability, or means I think probability is better, right? Because a lot of understanding is needed in probability and inequalities. I think you guys already have done that chapter, isn't it? So if time permits, we'll do it at the end. Will that be okay with you guys?
Yes, sure.
Yeah. Please tell me who's that. Hari Raghav. You're saying something? Okay, so limits and derivatives. You solve problems, all the problems from that exercise and miscellaneous problems. You did you try it and solve problems from that? See, because the only way you can learn mathematics is by solving problem. Okay, there is no other way. See, 3D geometry. Let's start. Let's not wait for the host access. We'll get in few minutes. See, in 3D geometry, we are not going to go into the details of vectors. Okay, vectors we are not going to study. Maybe until standard it is there. Okay, so coordinate system we already know, like four coordinate quadrants we know, right? In the coordinate system, we know four quadrants when we are studying only x and y axis. That means only when we are studying about xy plane, right? XY plane is also called Z plane. All right. When you are writing x and y, that means that is called Z plane or XY plane. Both name are same. Both are the same. When that means we are dividing the plane into 4 parts. Okay, and those 4 parts are called quadrants. Now when we have the third axis, okay, if we have the third axis, that we usually call the z axis. Okay, and right now we are studying only the rectangular system, no other system, coordinate system, only the rectangular coordinate system we are studying. So we have x, y, and z axis, 3 axes we have. Now if we have 3 axes which are mutually perpendicular to each other, that means it will divide the space into 8 parts. That means from origin we can go into 8 different quadrants. Okay, and these are not called quadrants, of course. These are called, what are these called? Anyone can anyone tell me what are these called? These are called octants because there are 8 divisions of the space, right? Now we are not on a plane, we are in a space. All right, so a space can be divided in rectangular coordinate system into 8 parts, and those are called octants. And the rules will remain same. Like if we have only 2 coordinate system, that means x and y, 2 variables. So the first quadrant represented positive x and positive y. Similarly, the first octant will represent all positive, means x will be positive, y will be positive, as well as z will be positive. In second octant, what do we have? Like x is negative, like we have in xy plane, right? In xy plane we have in second quadrant, what do we have? We have negative x and positive y, right? So similarly here also negative x and positive y will be there, but the z in the z direction it will be positive. Okay, so I have got the host. No, because just now I got the host access. I'll now share the screen.
Okay.
Yeah. So hopefully now you are able to see the screen, right?
Yes, sir.
Yeah, tell me. Yes.
Yes,
Yes. What happened?
Yes, sir. We can see
Okay.
this.
Okay. Where is it? Okay, new chapter we have to start, right? Okay. So this chapter, this is introduction to 3-dimensional geometry. Okay. Introduction to 3D geometry. Right. Now we have studied about 2 dimensions, right? So 2 dimension that can be represented. Now this is called our XY plane, right? X, Y, and this plane, whatever plane that we have, that can be represented. Of course, this is negative x and negative y. So this is called your XY plane, or this is also called Z plane, XY plane or Z plane. Okay. And we are only studying rectangular coordinate system, okay, or Cartesian coordinate system. Rectangular or Cartesian coordinate system. All right, understood? Now, see, now since when we had this in 2D geometry, what we have studied, x and y both are positive in first quadrant, x is negative and y is positive in second quadrant. In third quadrant, both x and y is negative, and in fourth quadrant, x is positive, y is negative, right? That's what we have studied in 2D geometry. In case of 2D geometry, we have studied this. Now, when we are saying 3-dimensional geometry, that means Now we are not studying about plane. Here we are only studying about plane. Okay, plane figures. Plane figures. Now we'll be studying about 3D space. 3D space. Okay, that means we have x-axis. Sorry, let's say this is y. See, any axis we can represent x. Let's say this is and z. All right. So this is x, y, and this is positive z. Okay, why this is positive z and not this is positive z this side? Why is that? Can anyone tell me? Can anyone tell me why this is origin, by the way? And wherever these three axes, these three are mutually perpendicular to each other, right? So x and y will make 90 degree with each other. Y and z will make 90 degree with each other, and x and z will make 90 degree with each other, right? Now, why is this positive z? Why not this one? Why? Anybody is having idea? Why that? See, we follow here right hand rule. You might have studied Fleming's right hand rule as well, right? So we have, if you put all your three fingers, your thumb, your forefinger, and your middle finger in mutually perpendicular direction, right? So the reason is different. We can understand using this right hand rule. Okay, so if y is the direct, if y is your force, and not that is Fleming's rule. Let's not say that. If y is your y represent, if this is your positive y and positive x, so you rotate your finger in which direction? X. If you keep your palm like here, okay, you keep your palm here, and your okay, it's difficult to explain using this. Let me use Fleming's rule. So suppose this is your thumb. What happened? This is your thumb. This is your, this y is your forefinger, and this z will represent the direction of your z is your what? Which finger? Middle finger. Okay. Now these three are mutually perpendicular in this direction, right? So these three are positive axes, right? That's why we write x cross y. In vectors, you'll study x cross y is positive z. Okay, that's why it is important to study using vectors, but vectors are not there in the syllabus. Okay, so it will always follow the same order. X cross y, we don't write x cross y, we write in terms of unit vectors, like I cross j is equal to positive k. Positive k means unit vector in z direction. I is unit vector in x direction, and j is unit vector in y direction. So it will always follow the same order. In the same order it will go, right? Like next you can write j cross k will be positive I. Okay, and again k cross I will be positive j. All other will be negative, and I cross I is always unity. Means if you multiply I unit vector with another unit vector, you will always get 1. That is valid with all j, k. Okay. So using that right hand rule, we can find out what will be the direction of x, y, and z. It means at least positive x and positive y should be given. All right. That's how we can find positive z. Okay. Let's do a problem based on this concept. See, suppose this. Okay. So if this is your y and this is x, okay, what direction is the third one? Like this is negative z, this is negative y, this is your negative x. So which one, z, this arrow represent what? Which direction? Will this be positive or negative z? See, keep your palm on x-axis. Okay, keep your palm on x-axis and rotate towards y-axis. All right, the direction of thumb will give you the z-axis. So which direction is that? This will be positive or negative z? Anyone?
Negative.
No, it is positive only, right? See, same, it's the same diagram. You see, check, it's the same. X, Y, Z, right? See, keep your palm here, like a right hand thumb rule, and rotate your fingers in this direction towards Y. Okay, your thumb will be pointing in this direction, in Z direction. Okay, like for example, if suppose you draw it anyway, it doesn't matter. Let's say this is Z and this is Y. Now you will Y cross Z is positive or Z cross Y is positive. It will follow the same order. Z and Y cross what? Z. So the second one, this one. Okay. So you keep your palm on y-axis. Okay, so keep your palm on y-axis and rotate towards Z. If you rotate towards Z, then this inside we represent by cross, right? Inside we represent by cross. Okay, I hope you know this thing. So this direction will represent positive x. This side it will be negative x. Okay, that's how we represent direction. So these are 4 octants. Now octants, what are the octants we are talking about? See, let's say this one. This represent your xy plane, right? Isn't it? This is your xy plane. XY plane. Now, which plane is this one? The red one. Okay, let me draw this. Which plane is this one? Sorry. Oh, I'm not getting it. But which plane is this one? You got it, right? You got the idea, right? Which plane is this one? Huh? This is which plane? This plane can be defined using x and z. We don't need y at all, right? So this is called xz plane or y plane. Just understand here. See, we are writing in terms of 2 variables, x, y. So when you write in terms of third variable, that means that variable must be perpendicular to that plane. That's why we are writing z plane, because z is perpendicular on xy plane. Okay. Similarly, y is perpendicular on xz plane. Okay. Now how you will represent yz plane? So this will be our yz plane. This plane will be our yz plane, right? So this is yz plane, or it is also called x plane, because x is perpendicular on yz. Understood? Okay, let's move ahead.
Yes.
Now the given octants, we have given octants. So first octant, let me draw it again. So let's say this, and this. Okay. So hopefully you can imagine it in 3D, although we cannot draw 3D on 2D plane. It's impossible. But just try to imagine. So x, y, let's say this is y and this is z, positive z. So of course this will be negative, and negative y. Now if you have any point in this plane, just try to imagine this plane here in this octant. Any point is there in this. Okay, so suppose any point is there on this not plane. How I should? Okay, so let's say some point is here. Okay, which travel positive x, okay, positive y, and some positive z. Then we reach here, right? Positive x. So this point P can be represented by positive, positive, positive. First we are writing X, then Y in the middle, and then Z. So in first octane, X, Y, Z all are positive. Got it? So which will be second octane? In second octane, X is negative. That means we have to come somewhere around here. Let's say the image of point P on this line. So let's say P dash. So P dash will be negative, positive, positive. This is our second octane. Okay, octant, sorry, not octane, octant. Okay, so this is second octant, this is first octant. Now which one will be third octant? See, in third octant, X and Y both are negative, Z is positive. Okay, so so image of this P here, let's say below here, means here somewhere and downward. So P double dash. Now P double dash will be negative, negative, positive. So you see, you're traveling it in the negative side. Now here it is going downward in the third plane. Okay. Okay. Now let's so this is your which octant? This is your third octant. Fourth octant is X will be positive, Y is negative, and Z will be positive. So it again travel to this side in the downward direction. Okay, so let's say P triple dash. So this is your X is positive, Y is negative, and Z is positive. Now you see, you will observe one interesting thing. So this third, this is fourth octant. How do you remember this? See, it is all your XY plane. It is all XY plane, but just Z is positive. So if you put again Z here, positive, 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 this will become your first octant. This is second, third, and fourth octant. Now, this all we are talking about positive Z. That means only Z is this side, only this side of the axis. Okay, only this axis we are talking about, this side. Z is always positive. So same thing if you go that side, that means it will be Z will be negative. So that will become your fifth, sixth, seventh, and eighth. So this will become your fifth, this will be your sixth, this will be your seventh, and this will be your eighth. Got it? So if you take the image of point P about Y, this axis on Z in the negative side, where you will get, let's say somewhere around here. So let's write point. This name is Q, and Q is in the fifth octet. So X is positive, Y is positive, Z is negative. Now all Z will be negative. This side, let's say Q dash. Okay, so Q dash. So this is your fifth octet, and okay, this is your sixth octant. So here X is negative, Y is positive, Z is negative. Now Z is negative all the time. So this is your sixth octant. Now seventh octant, you just travel in the downward direction. Let's say Q triple dash. Okay, so this will be your negative, negative, negative. All three are negative in seventh octet. And in eighth octant, we'll just travel this side. Where is it? Here, let's say here. So this is your Q triple dash. Okay, so this will be represented by positive X and negative Y, negative Z, and this is your eighth octant. Understood all the octants? So first, second, third. This is your first, second, third, fourth, fifth, sixth, seventh, eighth. Sorry, eighth. Understood? These are the octants. Now, any point can be represented. Any point on in space, right? In space can be represented by, let's say, some point P, which is x0, y0, and z0. Okay, by all these 3 points, anywhere in space, it can be represented. And on that basis, we'll decide on which octant it lies. Okay, now let's come to exercise 12.1, question number, let's say 1. Okay, question number 1, what is it? A point is on x-axis. Point is on x-axis. Okay, on x-axis. What are its y and z coordinate? Yes, if the point is on x-axis, what are its y and z coordinate? Y coordinate will be what? See, on x coordinate, it will be x0, some value x0. In y coordinate, what will be y0? 0, right? And z0 will be 0. Because the point is on x-axis, isn't it? Any point, so on, that means what? Let's write the conclusion. On x-axis, y and z are 0. On y-axis, x and z are 0. And on z-axis, x and y are 0. Got it? Okay, let's move ahead. Okay, so let's do problem number 3. See, name the octants in which the following point lies. So the point, given point is 1, 2, 3. In which octant it lies? Yes, which octant this point will lie? See, x is positive,
First
y
one,
is
sir.
positive, z first octant, very good.
Octant.
Yeah, correct. Now let's write -4, 2, and 5. Which octant it will lie? See, minus plus. See, first always check these two. If minus and plus, what is which quadrant it is?
Second octant, sir.
Second octant. Very good. So this will be second octant. This is second quadrant, and since z is positive, so it will be second octant. All right, very good. Okay, so hopefully you can solve. So let's say -3, last one, -1 and 6. Which octant will be this? Yes, anyone?
Third
See,
octant.
which one?
Third octant.
Third octant, yes, because these two represent your third quadrant, and since z is positive, it will be third octant. Okay, and if some point is like -3, -1, okay, +1, -6, which octant will be this? Minus, plus, minus. So first always check these two. Which quadrant is this two? In plane, xy plane, which quadrant it represent? Minus, plus. Second, right? And then z is negative. So opposite of second, which quadrant there it is? Check. Sixth, right? Yeah. So this will be in sixth quadrant. So sorry, sixth octant. Understood? Now, fourth problem number 4. What is this? Fill in the blanks. X-axis and y-axis taken together determines the plane. Which plane is this called? X and y. XY plane is also called Z plane, right? YZ plane is called X plane. And see, these are all positive plane. Okay. And ZX plane is called which one? Positive Y plane. These are all positive X, positive. Now, if you are writing YX plane, first you are taking Y, then it will be negative Z plane, because it will be in the negative side. Similarly, all others. Understood? Got it? Yes or no? This
Yes.
is really, it is easy, right, to understand. Okay, let's move to distance between 2 points. Distance between 2 points. Now see, any point, let's say in space, any 2 point can be represented like P, X naught, Y naught, Z naught, right? Some point given is P. Some point in space, let's say Q, X1, Y1, and Z1. Now the distance between these 2 points, how we can find out? How we can find out the distance between P and Q? See, in 2D plane, we know a formula, right? Distance formula. What is it? We have had the proof of that formula. We can also have the proof here. Let's understand using without proof first. Let's see the formula. What is it? Anybody knows? Is same that triangular method, that Pythagoras theorem we will be using. Okay, let me first write down the formula. Okay, so PQ, I know first everyone want proof, but let's try a different method. So PQ will be equal to square root of, okay, x1 minus x naught whole square plus y1 minus y naught whole square plus z1 minus z naught whole square. Okay, so that will be your formula. All right, let's solve a problem. So if point P is 3, 2, 4 and point Q is 7, 8, 9, what is the distance between these 2 points? Let's say 7, 8 minus 9. Yeah, what is the distance between these 2 points? Calculate it.
Root of x square minus x. I mean, root of x2 minus x1 the whole square.
Yeah. See, x2, x1 is given, no? See, PQ will be equal to what? Square
Yes,
root
sir,
of.
it's given.
Yeah. Find out. Tell me the value. Seven minus 3 square plus 8 minus 2 whole square plus minus 9 minus 4 whole square. Okay, this will be equal to 4 square plus 6 square plus 13 square. Okay, somebody solve and tell me the answer. Please don't use your calculator. How much is this? 4 square is how much? 16. 6 square is how much? 36. 13 square is how much? 169. Right? Add all three. How much you are getting? Yes, tell me.
223, sir.
220?
223, sir.
223. Are you sure? See, 9 plus 6 plus 6. 12 plus 9 is 3. Okay. Anyone else got different answer?
Right, sir. It's 221, sir. 221.
221 square root. So square root of 221 is the answer, right? PQ will be square root of 221 unit. Right? Okay, so that's the distance formula. But how do we prove it? Okay, how do we prove that it is this x1 minus the difference, the square of the difference between these two, the coordinates? Okay. Well, again, let's make the plane, obviously. Let's go through the plane. Okay, so this is, let's say, y, x, z. Okay. Now just imagine there is a point somewhere. Let's say in that, let's say where this point here, P, okay, which is x0, y0, z0, okay. And again, there is a point Q here. Okay, I don't know how I can show you on this. Okay, let's first find the distance between point P from origin O. Okay, this distance. Okay, now again this point P, this point Q, the distance from this origin, right? Then we will connect these two. Why do we connect these two? What we will get connecting these two? Tell me, yes. Anyone please tell me why? Okay, anybody, any other idea to find this, that the distance between PQ? See, one method is connecting with origin, another method, but for that we have to have some idea of vector. Okay, so first let's join these 2 points, P and Q. Okay, so this is PQ. Now see, to travel P, to go to P, what does x0 represent? It represents how much you are traveling in x direction, right? From here to here, let's say to this point, x0. Let's say this is x0. Then how much you are traveling in y direction? Here. Let's say here, this point. Okay, and then how much you are traveling? Somewhere around here, and in z direction. Sorry. Okay, this should look at least proper. So this distance is x0, this is your y0, and this is your z0, right? That's how. Now to reach Q, that means you will first travel x1. This point can be anywhere, right? First, let's say first you will travel x1, okay, then you will travel y1, let's say, yeah, y1 somewhere here, and then you will travel z1, someone around like this. Okay, so this represent your x1, this represent your y1, and this represent your z1, right? Now with using these 2 points, these two points can be diagonal of a cube. This can be represented as a diagonal of a cube. Okay, so that, it's like this. So let's make a cube. Let's make a fresh cube here. Okay, let's make a cuboid, actually, not cube. Okay. And in this cube, we'll try to cuboid, we'll try to represent x0, y0, and z0. Okay, let's say this point here, it is x0, y0, z0, and this point right here, it is, let's say, that is this x1, y1, and z1. Because these are all in, these 2 points are in different plane, complete different plane, right? See, this is one plane. Okay, this is one plane. These are all, all 8 sides represent 8 different planes, right? 8 different planes it represent. We have, sorry, not 8 sides, 6 sides, right? All 6 different planes it represent: positive x, positive y, positive z, negative x, negative y, and negative z. Okay, so if you name these points, let's say A, P, this is Q, we have to find the distance of these diagonal, right? Let's say from point this to this point. Okay, A, B, let's say B, C, D, E, F, and this is Q. We need to find PQ. This is P. All right. So in order to find PQ, now you see this plane. You might have studied in that solid that what is that name of chapter in chemistry? First chapter. What is that? That I completely forgot the name of the chapter. But in first chapter of chemistry, also in solid. So what is that? In physical chemistry, what is your first chapter? In physical chemistry. Okay, in that you'll be okay. Not in 11th standard, it is in 12th standard. I'm really sorry, but you have studied, FPS, right? FPS, face centered, body centered, these type of structures. In that you might have studied. In physics also, there are problems based on this, right? So how you will find this diagonal? How do you find the diagonal length of this diagonal? So this diagonal is also on some plane, right? Now, if you draw a line here like this, right? Let's say QB, and this also make B, this QB line is perpendicular with PB, right? So if we can find, now we know how to find QB, right? We know how to find QB, because what will be the coordinate of B, point B? It will be minus x naught, y naught, z naught, right? Not z naught. It is on the same line, right? So same line. So what is changing? Just z is downward direction, just y. So y is just changing. All other remain same. Sorry. So let's say y. Is that y is changing? Some value of y is changing. Okay, and so we know QB is perpendicular on BP. So you can write QP square using Pythagoras theorem is equal to QB square plus PB square, right? Now, how do we find QB square? So to find QB square, we can again use Pythagoras theorem. We know QB square will be, which we will be substituting here. QB square will be equal to what? QC square plus which square? CBC square. Okay. Now you will substitute it here. So we'll find QP square is equal to QC square plus BC square plus PB square. Okay. Now if you find this distance QC, QBC and PC square, because both it is on same plane, right? So the coordinate it will have is x1 minus x0 square. That's how you will find QC plus BC. What you'll find, because it is on that same plane, so y1 minus y0 square plus, now which PB is on Z plane, so you will write Z1 minus Z0 square. That's how you find the distance on the same plane, right? Because if it is on one axis, let's say if it is on x-axis, so how do you find the distance, right? We are squaring the distance, of course, and we are finding this. So how do you find square, right? So QC you will find how, if this point is Q, this point is C, this is on X, right? So QC will be what? The coordinate of this point, the X, let's say this is X1 and this is X0. See, X1 and X0. So that's what you write, no? X1 minus X0. See, that means Y and Z value is 0. That's what I have written here, right? On where? Yeah, on X-axis, the value of Y and Z are 0. On Y-axis, Y and Z are 0. Z-axis, X and Y are 0. The same thing we are using it here, and we can write directly like this. Okay, so no need to write like that. That means this we are getting is QP square. QP square, this is what we are getting. So QP will be equal to x1 minus x naught square plus y1 minus y naught square plus z1 minus z naught square root of all this. Okay, so that's what we have been using for distance formula between any 2 points in space. Okay, so let's go to the exercise. Okay, so write on the problem. So you have to find, see, it's given PA square plus PB square is equal to 2 times of K square. Okay, so you have to find the value of what can be point P. What are the possible values of point P? Okay, possible value of point P if A is 3, 4, 5 and B is -1, 3, -7. See, this is A and B is given and a relation is given, right? So you can you find this, the possible values of P? So let's assume, first you will assume that P can be what? X naught, Y naught, Z naught, right? Now find PA. PA square will be what? What will be PA square? So X naught minus 3 whole square plus Y naught minus 4 whole square plus Z naught minus 5 whole square, right? That is PA square. Now what is PB square? This will be X naught minus into minus will be plus 1 square plus Y naught minus 3 square plus Z naught plus 7 square, right? Now the a relation is given, so just substitute these two here, okay, and find out the values. So you can write X naught minus 3 whole square plus Y naught minus 4 whole square plus Z naught minus 5 whole square plus this. So X naught plus 1 whole square plus Y naught minus 3 whole square plus Z naught plus 7 whole square is equal to 2K square. Fine. Now just open the bracket and find out the values. Find the relation of X, Y, Z with this K. Find a relation. That means you just need to solve this equation further. Okay, that's it. So open the bracket and solve the equation. That's it. That's what you have to do. Okay. So then you will get an equation in P, equation for point P. Any doubt here, or anything is not clear? See, this is the relation we need to find out. This is, yeah, tell me, yes. Yeah, tell me, please, if there is any
No,
doubt.
sir, I didn't have any doubt. I understood.
You understood? See, I know there, it was a little hazy here in this, the proof of this formula. Just go through it once. See, I'm not able to draw a 3D picture here. Okay, and probably it might not be clear, but just go through once and I'm sure you will be able to understand. Okay, this the proof of this formula is exactly similar to the proof in 2D plane. Just you have one more axis. Okay, see, this is example number 6 of your book. Example 6 of your book. Let's come to exercise. See, exercise 12.2. Okay, so just same 2 points are given and you have to find the distance between them. That means you just need to use the formula. Okay, so let's say the question number 1, 3, -1, 3 and -4 and 1, -3 and 4. These are the 2 points given. Find the distance between them. So how you will find? Let's say this is PQ. So PQ will be equal to, or PQ square you can write. This will be equal to 1 minus 1 square plus minus 3 minus 3 square plus 4 minus so plus 4 square. So this will become 2 square plus 6 square plus 8 square. Right? How much will be this? 4 plus 36 plus 64. How much will be this?
104. Root
104. 104, right?
Yes.
Yeah, 104. So PQ will be how much? Square root of 104. All right, unit. Hope this is very easy. So how do you find, when do we say 3 points are collinear? When do we say 3 points are collinear? Let's say there are 3
They are
points,
in
right?
the same plane.
Yeah, see, it's not like in the same plane. Now, suppose if, let's say this is your, let's say these are the octants, right? I'm just representing the positive side, X, Y, Z. See, it may not have, see, line is always on the same plane, but how you will determine whether the same plane it is? Okay, so see, suppose the line, a line will be like this, right? We haven't studied about that plane property. That's why I'm not telling you about the plane. How do you prove that? Okay, let's say line, say, suppose this is the line. Okay, this is the line. So when do we say that the 3 points are collinear? Okay, let's say these are the 3 points. Okay, P, Q, R. When do we say this P, Q, R are collinear? In terms of distance formula. Of course, a line is always on the same plane. A line cannot be on different planes. If you have doubt, please let me know. Wherever the line will pass, it will be on the same plane. It doesn't matter in which dimension you are drawing. Okay, it's just the rotation of the coordinate system. It may seems like it is passing through X, Y, Z, but because we have fixed the coordinate system like that. Okay. So line will always pass, it will always lie on one single plane. Okay, so let's say the coordinate of this point is x0, or let's say 1. Let's write x1, y1, z1. This is x2, y2, z2, x3, y3, z3. Okay, now when do we say these points are collinear? Collinear points. Of course, they are on same line. That means the sum of these, first you will find PQ, then you will find QR, then you will find PR. Okay, the sum of any two will be equal to the third one. Then we'll say the points are collinear. Understood? So we don't know where PQ and R is. So in this case, only in this case, PQ plus QR will always be equal to PR. Okay, then we say the points are collinear. Otherwise, the points will not be collinear. Right? Got it? Okay. So using distance formula, we can find PQ, QR, and PR. Okay, let's move ahead. Now, when do we say it's a part of isosceles triangle or a right angle triangle? How do we say that? Okay, see, this was problem number 2 of your exercise. Okay, I want you to do problem number 3, 4, and 5. See, just try it yourself. Isosceles triangle, what's the meaning of isosceles triangle? What are the 3 types of triangle?
Acute, obtuse, and scalar. Yeah. No, sir. Scalar,
Okay.
isosceles, and
That see, which triangle is this?
equilateral.
Equilateral triangle, right? Now tell me, sorry, which triangle? Let's say I'm saying that 2 sides are equal. That means this and this side is equal, but this side is different. Then which type of triangle is this?
Isosceles.
Isosceles triangle, right? That means if these two angles are equal, these two sides are equal, that means these angles will also be equal. This and this angle is equal, right? Here all three angles are equal and they are 60 degree, right? Right? So this is your equilateral triangle, this is your isosceles triangle. And what's the third type of triangle? In which all sides are different. In which all sides are different. Let's say some triangle like this. So this side is different than this side and this side. That means all three angles will be different, right? So what type of triangle it is called? Scalene triangle, right? So so these are the three different types of triangle. Now, what is the property of right angled triangle? Can right angled triangle be equilateral triangle? Can a right angled triangle be equilateral triangle? Is it possible?
No, sir.
No, right? Because the hypotenuse is always greater than these two sides. Let's say in trigonometry, you have studied that this is called hypotenuse side. If it is 90 degree, this is, let's say P or B, whatever you want, B, and let's say this is P, okay? Opposite side. Okay, so we know H square is equal to P square plus B square, right? So it can be the scalene triangle or the isosceles triangle, but it cannot be equilateral triangle because one angle is already 90 degree. And we know equilateral triangle, it has all three angles 60 degree. So if it is equilateral triangle, that means these distances will be same, right? If it is isosceles triangle, that means at least two sides will have same distance. Yeah, the length of two sides will be same. This will be L, whatever value you will get, and this will also be L. This can be different, right? So this you have question number 3 of your book, means exercise 12.2. Okay, so in exercise 12.2, for first one is question number 3. First one is 3 points are given, are the vertices of an, you have to verify that this is isosceles triangle. Okay, that means you will see P, Q and R is given. You will find PQ using distance formula. You will find QR and you will find PR. See, if any two are equal, that means it is isosceles triangle, right? If any two are equal, that means it is isosceles triangle. All right. And the second problem is verify that right angled triangle. Right angled triangle, that means it will follow this one. You will find PQ. Okay. You will find PR. PR and QR. Okay. So it has to follow some relation like this. Some relation it will follow here. So you will find actually the square of all three. And you'll check by adding 2, the square of two sides, whether it is equal to the square of third side or not. Then it is right angle triangle. The third one, verify that these 1, 2, 3, 4 points are a parallelogram. So how a parallelogram look like? A parallelogram, right? Oh, what is that? Something like that. What is the property of a parallelogram? How you will verify that 4 points P, Q, R, S is given? So when do we say the figure is parallelogram? What was the property using distance formula?
Sorry, the distance between PS and QR are equal and
PS and QR. That means you will find all 4 distances, right? That's what you are saying.
yes, sir.
So this should be equal to this and this should be equal to this, right? Then it is a parallelogram, isn't it? Yes or no? Yeah. So that's how you, so this is the third one that you have to verify, all using distance formula. It is easy chapter, right? Relatively. you just have this one formula and which you have already studied in 2D geometry. That's simply we are extending this formula, this one. Okay, so you just have to use this formula and your exercise 12 point, which exercise is that? 12.2, right? 1 and 12.2 will be done. All right. Okay. No? Anything else you want? What is the next topic? Next topic is your section formula, which we are going to see next Monday. Okay. So next Monday we'll finish this chapter. The only one, I think, section formula is remaining, right? Or anything else? Where, let me check NCERT book one more time. Do you have any class right now? Just a minute. I just want to check this. Okay. Okay. So we have section formula. That's it. Yeah. So only section formula is there, and you have miscellaneous exercise. So shall we do section formula also? Well, you already have the formula in the book. Okay. And see if, okay, anyway, we'll be doing that on Monday. Let's not put a lot of load. Okay. So section formula we'll put, if you want, you can always do it, but we'll see it on Monday. Okay. Thank you.
Thank you, sir.
Just solve the problems. It will be easy. Okay. This is a very easy chapter.
Yes, sir.
Yeah. Bye.